Okay. Good day, students. My name is Mr. Timothy Olawale, and I'll be teaching you on inequalities today. All right. So, inequalities. I want you to take note of this. Are algebraic expressions. Algebraic expressions. All right. That involve the following symbols. So we have less than, greater than, less than or equal to, and greater than or equal to. So these are the symbols that if we see them in an algebraic expression, we can say this is an inequality. All right, so this is less than, this is greater than, this is less than or equal to, this is greater than or equal to. You get that? Okay, so less than, greater than, less than or equal to, or greater than or equal to. So those are the symbols that are usually involved in solving inequalities. Okay, now I must say this, that between let's look at something like this. 2x minus 1 equals to 5. 2x minus 1 less than 5. Okay, so you see, this is an equation, this is an inequality. Now if you solve this, it's going to give you a definite answer. If you solve this, it's going to give you a range of answers. So a normal equation will give you definite answers. Like if you solve this 2x minus 1, you should get x equals to 3, right? All right, but this will give you a range. So what we are looking for in inequalities is a range of values. Did you get that? All right, so now we have a lot of similarities between solving equations and solving inequalities. So we're just going to go straight to examples. All right, so solve the following inequalities. A, 2x minus 1 less than 5. B, x plus 3 greater than 2. C, 4x plus 6 is greater than or equal to 3x plus 7. All right. D, 3x minus 5 is less than or equals to 3 minus x. Pay attention. Okay. Then E, we have minus 2x plus 1 is greater than 5. Minus 2x plus 1 is greater than 5. So we want to solve these inequalities. I want you to pay close attention. So let's start with number 1. Okay, 2x minus 1, okay, is less than 5. Now you are solving it like the way you solve a normal equation. This minus 1 can go to the other side conveniently. We have 2x is less than 5 plus 1. 2x is less than 6. All right, so we are dividing both sides by what? 2. Okay, so we have x less than 3. So this is the answer, or this is the range of answers. Okay, and then you may be asked to represent these answers on a number line. Represent this answer on a number line. All right, so how do we do that? Pay attention to this. We have something like this: 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4. You know, this is a number line. And you know x is less than 3. So we have something like this. And because it is less than, it goes to the other side. So this, anybody that sees this knows that this is x less than 3. So this is like a sort of a graphical representation of the answer that we got. Is that clear? All right, so let's move further to the next question. The next question says that this is A question, this is B question. Okay, we have x plus 3 greater than 2. This can conveniently move to the other side. We have x greater than what? 2 minus 3. Remember, when plus moves to the other side, becomes minus. So we have x greater than minus 1. Do you see that? So we have x greater than minus 1. Then we have something like this: 0, 1, 2, 3, 4. We have minus 1, we have minus 2, we have minus 3, we have minus 4. All right, and then we have minus 1. It goes like this, and then it goes to the right because it is greater than. Greater than we go to the right, less than we go to the left. Is that clear? Greater than we go to the right, okay, less than we go to the what? To the left. Okay, now let's go to the third question, this third solution. We have 4x plus 6 greater than or equals to 3x plus 7. Okay, 4x plus 6 greater than or equals to 3x plus 7. So we have 4x minus 3x greater than, we are collecting like terms now. Collecting like terms. 4x minus 3x is greater than 7 minus 6. So we have 4x minus 3x is what? X greater than what or equals to what? 7 minus 6, 1. Did you see that? So our answer is x greater than or equals to 1. So how do we do that? We have something like this: 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Okay, so we have greater than 1. We have something like this. It goes to the right. It goes to the right. Okay, and because you see, this is, look at this, the big question. This is x greater than 1 minus 1. Now this is x greater than or equal to 1. So this equal, now we shade this place. Shading this place differentiates it from every other one. So whenever you see this shaded, there is an equal to attached. Is that clear? All right. Is that clear? Okay, so let's try out the third question. Let's try out the third question. Let's try out the third question. Okay, sorry, let's try the fourth question. The fourth question says 3x minus 5 less than or equals to 5 minus 3 minus x. 3x minus 5 is less than or equal to 3 minus x. We collect like terms. We collect like terms. Okay, so we have 3x plus x less than or equals to 3 plus 5. 3x plus x is what? Is 4x. Is less than or equals to 8. We divide both sides by what? By 4. So we have x less than or equals to 2. Is that clear? We have x less than or equals to 2. Okay, so we can represent it on the number line. We have something like this: 0, 1, 2, 3, 4, minus 1, minus 2, minus 3. Okay, and then this is 2. Because there is an equals to here, we shade this, and then it is less than, right? So it's coming to the left. Is that clear? It's coming to the left. Okay, so let's take the fifth question. Let's take this fifth question. We have minus 2x plus 1 greater than 5. Minus 2x plus 1 greater than 5. This one can go to the other side. So we have minus 2x greater than 5 minus 1. Minus 2x greater than 4. We are dividing both sides by minus 2, right? Now pay attention. Because we are dividing both sides by minus 2, okay, the sign changes. Pay attention. Because we are dividing both sides by a negative number, the inequality sign will change. Because whenever we divide both sides or we multiply both sides by a negative number, the inequality sign will change. So minus 2 cancels minus 2. 2 here, 4, 2 here, 2. So We have x, because we are dividing both sides by negative, this will become x less than what? Minus 2. Please pay attention. Pay attention. If a negative number is used to multiply or divide both sides of an inequality, the inequality sign changes. Okay, the inequality sign does what? Changes. So we have something like this representing on the graph: 0, 1, 2, 3, minus 1, minus 2, minus 3, minus 4. So we have something like this. Something like this, okay? So you see that there is no equals to, that's why this is not shaded. Is that clear? Is that clear? All right, so that's about that. I want us to take note of what I said, okay? If a negative sign, negative number, multiplies or divides, okay? If a negative number multiplies or divides both sides of an inequality, the inequality sign changes to the opposite. Please take note of that. Changes to the opposite. Is that clear? Is that clear? All right, so we stop there for now, and then I would give you classwork later on. Thank you.